This is the Average Guy Network, and you found Cyber Frontiers, show number 5, recorded on June 28th, 2014. Here on Cyber Frontiers, we explore cybersecurity, big data, and the technology shaping the future through an academic perspective. I am Christian Johnson, broadcasting live from College Park, Maryland on the AverageGuy.tv network. Never on a schedule, but always up to date, where we post the show and the show notes out at theaverageguy.tv. If you have questions, comments, or contributions, you can contact us via email at podcast@theaverageguy.tv or find the show on Twitter at theaverageguy.tv. You can now also call in your questions at 402-478-8450, and we'll play those right on air for our next show. Don't be afraid to use that. We always love hearing from you and having questions for our next show. I'm really pleased this week to have a special guest on, Joe Klein, who is currently the CEO of Disrupt6. He is a cybersecurity expert, 30-plus years, and has been in the IPv6 space and mobile technology space for some other years. Joe, it's good to have you on.
Pleasure to be here.
And also with us today, we have Gary Johnson, who will be helping us moderate our chat and keep the question pool moving. It's good to have you on as well.
Thank you.
So I really wanted to get into, so just to start, Joe, give us a little bit of background about how you got involved in the cybersecurity industry and what you've been spending your most recent time on, and where you're going with that.
Okay. Actually started over 30 years ago. Took a class years ago, and one of the challenges I was given was to do something unique. And at that point, it was a mainframe, so I decided to learn how to walk memory in a mainframe. Just happened to do it during the finals week, so the professors were editing their documents. So my deliverable was the code and several of the professors' finals. But then I started getting responsible for, they asked me to take over security, which was interesting. So that was years and years ago, and I've done lots of crazy things like that on the way. Recently, I decided that now that IPv6 is pretty dominant, that it's or is becoming dominant, that the security products are missing. I started it through a cyber incubator called Mach 37 to kick off and start a new company, Disrupt6, which is focused on the security of the next generation internet.
And so when you talk about the next generation internet and IPv6, I know a lot of people have been skeptical for years now about, well, are we really going to IPv6? Is that something that anyone is actually using? And by and large, even the people that I still talk to today very often say, no, we want nothing to do with IPv6. Is that something you would agree with, or do you think that's changing?
Well, 2002, or excuse me, 2012, we had June 6th, where we had a kickoff day, global kickoff day for IPv6, where IPv6 went live. At that point, there was approximately 0.06% of the internet prior to that was IPv6. As of today, just in the United States, we're at 9% of users are using IPv6. Most of them don't even know it. If you're using Verizon or T-Mobile, you have a high probability of using IPv6 versus v4. Also, if you're using Google Fiber, you have a 90% chance that you're using IPv6 versus IPv4, and that's increasing with all the not only national but international users throughout the world. So my focus has really been on how do I secure this technology, because it's just like all technologies, somebody has to look at it and critically to see what the security problems are.
And just as a kind of a quick refresher, what is it about IPv6 that makes you convinced that we really have no choice to go to IPv6?
A couple things. The whole reason IPv6 was architected was a little bit background. In the early 70s, Vint Cerf kicked off the IPv4 infrastructure with three assumptions. One was that there would only be 4 billion devices on his demo internet, that there would all the systems would be secure by default, and no system would attack any other system. In the early 90s, it was recognized that, well, none of that's true, and the projection is that we'd be out of addresses very quickly. At that point, that started a whole flurry of activity in the IETF to implement a new standard based on more addresses initially, but then also recognition of the security issues and operational issues, including many, many neat features that add new capabilities to the protocol. So that's where it kicked off, and like I said, today we're at a pretty good clip. We are doubling the amount of users about every 4 months, 5 months now, which is pretty significant.
So, and one of the big things that I always hear is that people are reluctant to move to IPv6 because of the challenging, well, really just the fact that there's so many different possible address schemes, and you have 4 different types of IPv6 addresses, and the common argument is always, well, why not just use NAT? And I will NAT all my devices behind 1 or 2 IPv4 addresses, and those will all be able to communicate in and out, and I don't need as many public IP addresses, and we could actually scale back our number of public IPs used if we went to that system. What really is it for you that makes IPv6 a more potentially secure solution than having all your devices natted and routed behind an IPv4 gateway?
Number one, NAT requires a lot of additional software for every single application just to be able to keep what is referred to as NAT Keep Alive. NAT Keep Alive basically is a regular either TCP or UDP connection that opens up your firewall outbound connection. And it's not only very noisy, but that happens with every single application to maintain a connection, number one. Number two, that there is no point-to-point connection, even with a NAT Keep Alive. You always have a third-party intermediary. With IPv6, with an end-to-end, the reestablishment of the end-to-end model, you and I can communicate without any intermediaries, proxies, additional devices that increase in latency and decrease performance on what we're doing. Also, it'll simplify a lot of the protocols. There was a list a while back that somebody put together from IETF, which was 90 major changes to protocols because of NAT that will be able to be removed. As an example, Skype, almost 10% of that code is just dealing with NATs. How do I maintain a connection through a NAT, and how do I get that connection out of that NAT? So again, that Keep Alive issue is a big issue. It also impacts mobile devices. For every application, I'm burning more electrons. I'm using more power. Several studies have shown that for mobile devices in the Internet of Things, we can decrease or increase the battery life by anywhere from 10 to 20%. So to get rid of the intermediary is a big issue. To be able to do end-to-end is a big issue with better performance and less hops is a big issue. And again, battery power is also an issue. So this also becomes an issue for Internet of Things. If we're going to grow to 50 billion devices by 2020, the cost of just the NAT Keep Alive, there was an estimate of something like 26 additional electrical plants will have to be implemented in the United States just to deal with the cost of the NAT Keep Alive, which is pretty significant. I mean, that's pretty crazy.
Sure, yeah, absolutely.
So, there's some significant improvements. Also, if I'm putting up all these Internet of Things, the whole goal here is to have machine-to-machine communications. If I have a NAT, I never know if I'm really communicating with that other endpoint. Again, because we have an address disconnect, we can't actually validate that that's the source of the communications. It could be something else.
Right.
Um, so yeah, there's a lot of security problems we've dealt with and we've kind of overlooked. IPv6 is allowing us to rethink and go back to the earlier days of, again, the end-to-end connection.
Now, what is it about IPv6 that allows it to communicate with other devices without a NAT? So try and, because I don't think, at least from a very top-down approach, understanding, what the difference between a multicast address, a local link address, a global address, and how that actually works from end-to-end communication. I think that's an important thing for people to understand because I don't think a lot of people are actually aware of how that works.
Okay, well, let's talk about the types of communications. First, we have unicast, which we've always had with IPv4, which is your connection to me. Very advantageous if there's a small community of people, but if I have a larger community of people, my cost of making all those connections are higher. Plus, again, I have to have an intermediary
Hmm.
to transmit that data.
Right.
Okay? So that has an advantage. Multicast allows you, Christian, to be able to take one data stream, allow the routers to do the rebroadcasting, not a server, and then to be able to communicate with, let's see, Cisco did a test that they were able to get to somewhere around 20 million people doing multicast, one data stream to each endpoint, and then the routers in between would actually make the decision of whether they duplicate that or turn that connection off. So that's a lot more efficient than, again, lots of unicast connections. A good example of this is, say we're having a hurricane, everybody in the world wants to view that one web page. Wouldn't it make sense for them to push a live update so everybody that wanted to have that connection, it would be one connection, it would be more real time, and you wouldn't put the load on the web server, as an example. Um, so that's the difference between unicast and multicast. Anycast has an advantage that it finds the closest source of the connection. So Anycast has been used in the DNS infrastructure for many years. So if you're in Maryland, I'm in Virginia, we're going to use the closest DNS server so that we can get the results as fast as possible. We're not going to actually do a DNS query to Africa, as an example. We're going to, again, go as close as possible. Those three actually provide better manageability and better control of throughput, better control of getting access to stuff, essentially.
And so how does the what is really this what are the security issues with having a global linked address for every device in your network? Is that not a pretty easy entry point that if someone compromises that one device with an IPv6 address, they then have access to tunnel through the rest of your IPv6 network?
Well, there's actually a couple things. Most organizations are implementing stateful firewalls. Most NAT firewalls are also stateful. So there's two components.
Right.
NAT just hides and rewrites the address, where it's a stateful firewall that provides true security for the endpoints. That's going to reduce a lot of code and improve performance just going through firewalls. But a couple things. Number one, if I'm a home user with a /64 address, that's 2 to the 64th power of potential addresses at my home. If my devices are randomly addressed, and those random addresses are changing on a regular basis, that's called privacy addresses. The ability to identify or scan in that space would take millions of years. Even for your just one upstream, they'd be able to find your upstream router, but beyond that, they really wouldn't be able to scan it. And there are now techniques that are being designed that if you see this kind of scans, your firewall can make choices to start disabling the source of the scan. So that's kind of a really big deal. For outbound, again, the ability for me to use protocols like DNS-SEC and DANE. DNS-SEC allows you and I to register a trusted path or a trusted public signature as an example, and I can use a protocol like DANE to validate that you're communicating with me, that I'm communicating with you, and we can share keys end to end. Again, we can't do that easily or quickly or trustworthy, at a trustworthy nature with the current IPv4 infrastructure because of NAT and because of the dozens of intermediary boxes that we have to fully trust. Does that make sense?
Sure.
So
Sure.
from a commercial standpoint, this has a real big advantage. The ability for me to have my DMZ up on the internet and have minimal connections. Currently, if I have a web server as an example or multiple web servers, currently IPv6 only connections are fewer hops, which means lower latency. Usually a trace route, I didn't do a trace route between you and I, but the trace route is typically in the 30 range. The typical trace route for IPv6 infrastructure is anywhere from 12 to 14. So it's relatively small, so there's a reduction in latency there. We've also started seeing better throughput through the replacement and redesign of this router infrastructure to support IPv6 has basically added better throughput, again, upwards to 20%, which again is significant if you're doing a web service. For the Internet of Things, the ability for me to identify where that endpoint is and do it securely, and for the endpoint to make a decision whether it needs that you're a trustworthy player that I will allow you to connect to me. Again, without all those intermediary things, we really do improve the security models that we have today.
So where does this stop in front of the average guy? I mean, at this point, my ISP isn't giving me an IPv6 address, and they haven't really given me any indication that they ever will, yet alone that my hardware will be ever be able to support it. Is there really any entry point at this stage for individuals who are not in an enterprise network environment to configure their own home network or other networks to be IPv6 enabled?
Absolutely. Let's go to the devices on your desk as an example. If you're running Linux 2.6, current versions of Mac or current versions of Windows 7 or beyond, those devices already support IPv6. If you're using the new Xbox, if you're using a lot of the newer devices, those devices already support IPv6. So we've taken care of the endpoints. The next is the switches and the routers. A lot of consumer routers and switches may not fully support it. The new ones do within the last 2 years. There's also still routers being sold that don't support IPv6 at all. So be aware of that. Rebuying anything for a home user is expensive. So I actually have a dozen out there that I've been testing, and they seem to work, but I have a few that don't. And if all else fails, you can always reflash your home router with WRT54G, the OpenWrt, and other open operating systems for a lot of these routers, and they support IPv6 by default. Okay, so that's the consumer getting to the router. The next is the next hop up to the internet service provider. One of the things I found is it depends on your carrier, your ISP. Some of them already have IPv6 to the end user. They've just never upgraded their router. A good example is Comcast. There's a lot of Comcast routers that you would get IPv6 if you replace the router, but they haven't gotten around to replacing the routers yet. Where others, you have to go through what is called a tunnel. And there's if you go to Wikipedia, you can get a list of IPv6 tunnel providers, which is, by the way, very handy if you want to do testing of connections around the world, because those connections come out in other places in the world.
Sure.
The one that I highly recommend is he.net. That's hurricaneelectric.net. They're probably the #1 connected IPv6 provider right now. The setup is relatively easy to do and easy to configure. 10 minutes, 15 minutes at most. They will give you a anywhere from a /64 to they give you a /48 if you want. /64 means that your upstream router has one address, that's the /64, and that you have 2 to the 64th power devices on your local segment. Okay, but if you're a crazy man like me, you may want more routers than the normal home user. So I have a /48, which gives me a lot more routability at my edge, even with my home, network, which is pretty cool. And then again, each segment can have 2 to the 64th power devices. So I don't think at my home I'm going to run out of addresses anytime soon.
For sure.
Okay. So once you do that, then you start getting access to the IPv6 internet. That's real interesting because there are now IPv6 only web services that you can't get to with IPv4. You'll also notice some really cool logos and things like that that will pop up that actually say you're running IPv6 versus IPv4. And again, there's a lot of countries that ran out of IPv6 or IPv4 addresses early in the cycle, 2, 3, 4 years ago, and they have many times IPv6 only web servers. So as an example, Norway, Sweden are moving to it. There's Japanese, Chinese, Asian sites that are IPv6 only. So those that are only on IPv4, they don't get it. Now,
Sure.
the third and cheating way, or maybe not the cheating way, the most expensive way, is that both T-Mobile and Verizon, you can tether your cell phone, and they support IPv6 by default. And honestly, when I'm traveling, that's the best way for me to create a trusted SSL or IPsec connection back to my office.
And is that only Verizon and T-Mobile right now?
At this point, yes. There have been AT&T has been promising it. We still haven't seen delivery. Most of the other providers we haven't seen delivery. We're waiting. It's just like Verizon cell phones, wireless does a great job. Well, Fios doesn't. Fios, what I understand is that a lot of the ONTs are going to have to be upgraded. So
Sure.
again, this is a big infrastructure upgrade.
And with that infrastructure upgrade, is it still going to be one of these things where for an interim period we're supporting both IPv6 and IPv4, or if I set up an IPv6 tunnel, am I going to be able to still get route to IPv4 web addresses? Will those services take care of that routing for me?
Well, there's actually a couple things. Number one, the way the IETF is written standard, when you're on a dual stack environment, you will prefer IPv6 over IPv4. And again, you get better performance that way, so that's not a big deal. So those that have actually moved to dual stack, yes, that's the way a lot of people are moving. But there's a lot of organizations, as an example, T-Mobile implemented a protocol called 6LAT. And what that protocol is a little bit of shim software on the phones that allow them to tunnel IPv4 over IPv6, terminate at a server at the edge of T-Mobile's site, and then only have IPv4 out there. That's becoming all the fad at this point because it's less expensive, anywhere from 6 to 17% to run an IPv6 only infrastructure than dual stack or an IPv4 infrastructure. So a lot of businesses and organizations are seeing that as a benefit. A good example of that is, I assume you use Facebook.
Absolutely.
Facebook is IPv6 internal.
Interesting.
They have dual stack on the edge using proxies, but they found it far more effective to manage their infrastructure with an IPv6 only internal infrastructure. Because as an example, say that I have a rack of servers and systems and everything else.
Right.
I have to allocate unique IP addresses on each of those for IPv4, and that's kind of a pain. What they've done is they actually have a /64 for that whole rack. So anything that goes in that rack will have an address no matter what. So if I upgrade to a 44 core device and I actually want access to every one of those unique devices, I don't have to change my address plan. My life is easy, so I have some
Sure.
expandability. So kind of
Yeah.
cool. So those are the ways that you can move to IPv6 and do it, as a home user and also as a business user.
And it's funny though that you mentioned that, you get all these addresses and it makes doing data center planning and management a lot easier, but it's also clear that a lot of people haven't done that. Why don't you talk about what Microsoft's challenges have been with the Azure cloud and what that means for them going forward?
Yes. Well, many of the cloud providers have chosen to do IPv4 only and have put a lot of investment into the network and other infrastructures. Microsoft is a good example of that. Their Azure is only IPv4. Well, about 2 weeks ago, they ran out of IPv4 addresses in this country to be able to serve customers. So until they could get more addresses, they wouldn't be able to serve more customers.
Right.
That's kind of a big impact for anybody, especially their customers that want to add more devices to communicate with their customers. So they were forced to grab a block of addresses out of South America. Well, the question was the block of addresses pulled out of South America so they could get out more IPv4 addresses here, or were workloads, data, and processing moved down to South America? And we've not gotten adequate discussion of that or feedback from Microsoft at this point. But this is very concerning from a security perspective. What if I run out of IPv4 addresses and my only choice is to take my website, which may contain really important data and financial transactions and such, and move it someplace that's outside the regulatory constraints of the United States or the privacy constraints of the United States? This is a growing concern right now with IPv4 running out of addresses.
Sure. And obviously some interesting privacy implications of that as well.
Yeah, privacy and security. I mean, think about HIPAA. I don't have to manage the network exactly the same way or the data if in another country versus the United States.
Sure.
So that has real concerns for anybody that has healthcare with anybody.
Right. And so is the distribution and allocation of public IPv6 addresses is it a similar method to what they currently do for IPv4 to register and receive blocks of addresses from the Internet Association?
Well, there's actually, let me kind of define how the infrastructure works. First, you have the IANA, which is responsible for all the addresses. They allocate blocks of addresses out to the 5 RIRs, or regional registries. And then each of those regional registries actually hands it out to internet service providers and/or consumers, and organizations. Well, up until let's see, it was 2006. The carriers thought that they were the only ones that could have IP addresses. So they were fighting to disallow companies to ever have portable addresses. So if a company wanted to move from one ISP to another ISP, they wouldn't have that ability. Well, myself and a bunch of us stood up at an Aaron meeting and made really good arguments and the impact of that on our businesses. I was working for a large business at the time, and they actually created another class of addresses, which are portable addresses for IPv6. But up until this point, you have to justify why you need a portable address. So in most cases, for a consumer or for a small to medium-sized business that isn't running the BGP protocol, you would get an address that your internet service provider gave you, or a block of addresses. If you have BGP or a large international company, that's where you can get these portable addresses.
And what's the advantage to having a portable address in that scenario?
Oh, in that scenario, you're using the same address range every place. It just makes it flatter and easier to manage the infrastructure.
Right, gotcha. And with that, the economy aspect of how much it costs me to get a static or a public IPv6 address versus an IPv4 address stays the same, goes up, or goes down?
Right now, for you to get a /64 from an ISP is free. Once your ISP provides it. For an IPv4 address, the prices are getting expensive. They were at $16 a few weeks ago. They're expected to be in the $100 range. Well, what's interesting is that for you to get just a single address, you also have to burn 2 additional addresses, which is the multicast and the scoped for IPv4. So if I wanted to get just a single address, I have to buy 3 addresses, which makes it really expensive. Where IPv6, the price of a /32 is relatively cheap.
Right, and so if you're getting these IPv6 addresses and you're running services like a web server or so forth, are you able to recreate your own tunnel back out to the internet that will resolve IPv4 traffic coming in, or do you still need to maintain that? It's similar to what we talked about with going out to reach sites, but is it the same for coming back inbound?
What a lot of organizations are doing is putting load balancers, which are IPv4, IPv6 is what Facebook's doing. They put a load balancer where there's only 1 or 2 addresses, and the load balancer then breaks out the load internal to the data center to tens or hundreds of additional servers if they're running IPv4.
Sure.
Which is a difficult issue because you have to have a load balancer. In IPv6, you could have those 100 servers and a user would just be allocated a random address to go to that server at that time. So a little bit of a different mode, but yeah, that's actually what's happening today in the data center.
Gotcha. So we're now at this stage. So all right, you've convinced me that IPv6 addresses are going to become kind of the next set of what we're doing on the internet. But what does that mean for, or let's start with what actually is the Internet of Things that everyone talks about? It seems to be one of the largest buzzwords out there right now, along with big data and some of the other flashy ones on the internet. So is that?
There's only 2 more. I'm playing buzzword bingo over here. Damn it! I'm waiting for you to give me another one.
Sure, sure. So well, let's start with Internet of Things.
Actually, based on the security issues, I refer to it as the Internet of Broke Things. Mostly because those that have implemented the technology today haven't looked at security. But the Internet of Things actually covers anything that could have a wired or wireless IP address. And that includes all kind of things, even things that have surprised me. Everything from building controls. So within a building, you can have boilers, you can have electrical, you can have your lighting, your security, your cameras, in one building. You have homes, which are they dealing with internet television and video and audio and your lights and your health systems you may have, your alarm systems within your house. We have automobiles and transportation, where we're talking about transportation devices that will communicate with other transportation devices. As an example, there's an IETF standard that's been created for car-to-car communications. It's IPv6 only, which is pretty interesting.
Hmm.
We also have healthcare systems, which are becoming very, very popular in the space. SCADA devices, that's another thing that we're seeing moving to exclusively to IPv6. So pretty much anything you can imagine that can have an internet device. And some of the things, again, I was real surprised at what people want to put connections on.
Yeah, I still remember Brian David Johnson, who's the futurist at Intel, is obsessed with this concept that, by 2030 everything is not only going to have a silicon chip in it, but now this aligns with this newer internet architecture where not only is everything kind of censored based, but they're all addressable as well. So it makes you wonder how much people have actually thought about the security of having everything in their environment addressed.
It's been discussed from a policy standpoint, and there's a couple proposals from different organizations to add the security. The problem with it that it hasn't trickled down into deployment of real products from the vendors, and that's also not trickled down to the enterprises on how they're going to secure it. I mean, honestly, I've done pen testing, I've done defense, I've done pen testing and have gone into buildings that have things connected that really surprise me, that should never be connected. Oh, their badge system to keep people in and out are also connected to their internet connection. Could this be a problem? Well, yes, it could be. Did I demonstrate that I could open the doors by accessing this system? Well, yes, I did. It proved that it was a problem. Oh, and by the way, they said they were protected by NAT at the time. I just want to bring that up, but they weren't. It was pretty funny. So yeah, it concerns me that we haven't designed the security protocol already. So we're going to have at least 1 to 2 generations of technology that are going to roll out and not be secure.
Sure.
And cause more compromises or loss of privacy or security or data or whatever.
Yeah, and do you think that I can't even imagine the amount of streaming data that's going to start happening once we're at that level of communication? I mean, do you think that will start to become more of, well, we have more communication coming through local networks that isn't being seen by the whole internet, or do you think that that's just going to ramp up exponentially as people start to adopt the IPv6 platform?
Well, I think that you're going to see a lot of more local communications. Let me give you a good example. I understand Comcast has got a program to use BitTorrent using IPv6, using multicast. And the reason they're doing that is if you're watching the same show as I'm watching, why should they have to pump multiple data streams down to a neighborhood? It makes more sense than one data stream. Well, what if you turn the television on 1 minute after I did, but you wanted to catch the show right from the beginning? Wouldn't it make sense for you then to communicate with the device in my house to get that first minute and pull it over to you local versus backhauling it to someplace else? So yes, I think that type of thought process is now being considered for this Internet of Things, pretty much a machine-to-machine type of communications where data can be shared locally and regionally and nationally, internationally.
Sure.
So taking a step back a little bit, just from a layman's, the average guy perspective, it's obvious that we're in the early stages of a transition and a sea change in what's going on the Internet. How do you foresee the rolling of this out, in the sense of, is this going to continue at a steady rate and all of a sudden we're going to look back and see it's happened, or is it going to reach critical mass at a certain point and open the floodgates where everybody makes a transition? And if we go from where almost everybody's on IPv4 and then we go to the double stack model, how long do you foresee it to where IPv4 becomes as obsolete as the plain old telephone system and just gets dropped right off, and there is no more legacy IPv4? And looking at even further out, is there going to be some kind of cultish advantage to actually owning an IPv4 address, that when the rest of the world is on IPv6, it's like, wow, I wish I really had an IPv4 address of my own?
I'm old school. I've got IPv4. I can just hear you saying this.
Just wondering. That's all.
Yeah, actually, I've been in meetings in the last month with multiple clients going, so what day should I expect that 50% of the internet is going to be IPv6? Well, that day's coming soon. That day's coming within the next 3.5 to 4.5 years based on the current growth rate. So I think that as of this show that you're doing, and beyond that, a lot of people's eyes are going to be woken up to suddenly realize, wow, I've been using IPv6 already. I didn't even know it. Okay, so I think that's already occurring. As far as disabling IPv4, IPv4 is going to be a long tail problem, and that is that there's IPv4 only products still being sold today. And obviously in the consumer and in the enterprise, that changeover may take 7 years, 8 years, 15 years. You know, if I buy a car, I may keep a car for 10 years. If my car had IPv4 in it, then when I received it, then I may keep it, you know, it may last 10 years, or a computer, or, you know, whatever it is. So yeah, we'll see a flip, just because the cost of operating a network with dual stack is more expensive. It's about a third more expensive to operate both together. That people are going to move, just like Facebook already has, to IPv6 only environment. But then I think eventually we'll see things decrease. But you know, honestly, there's still mainframes out here, you know, when we were kids, that are still being used today by large banks and things like that, and they support SNA, and they have FPE or front-end processors that are IPv4 only. Still running COBOL. Yes, Chris, and that's this old program from years ago.
Before my time.
You don't study that anymore, youngster? No, just kidding.
And Fortran and
yeah, Fortran. There you go.
So what do you see as being the research outcomes of this? Obviously, I always advocate through an academic perspective. So do you see big areas of research popping up for IPv6?
Oh yeah, I think the security models and provable security, or close to provable security models, when you don't have intermediary boxes, will be a interesting mathematical discussion and interesting security discussion. Implementing secure stacks right now, that's a real challenge, and also implementing the newest standards and to see what the security vulnerabilities of yesterday's standard versus today's standard. Just with IPv6, there's been 4 major waves of IPv6 standards that have gotten rolled out, and each of those standards provides more and more features, but the ones before actually opened up security problems. So, you know, doing regular testing of, you know, well, I'm using this particular protocol versus that extension of the protocol, well, this is going to break, or this is going to be fixed. From an innovation or a business standpoint, I think that the IPv4 products are running out of steam, and the security models they dealt with, the Maginot Line strategy that didn't succeed well with France in World War II, has now failed everybody, and everybody's just buying more stuff to try to deal with this. And I really think that comes down to the IPv4 security model today. And this is really where I think it would be interesting from a research standpoint. RFC 1918 doesn't just define the IP address ranges. If you read further into it, yes, I actually read RFCs, pretty frightening, huh? Also, legal and IEEE papers, but that's a whole nother discussion. What it discusses is that we're going to have, the security model was that we were going to deal with 3 types of infrastructure. We're going to deal with devices that needed to have access to the internet, and they would have a public address. This is after, you know, our NAT was introduced. We would have a second one where we would be inside the organization, but we would go through a proxy or some kind of disintermediary middle box
Right.
to do our work. And then we would actually have boxes that didn't have addressable capability off our segments. Okay? All 3 of them make sense. So in other words, and the IPv4 model, if we go on the internet, we trust everybody on the internet. If we are on our local internal network behind the NAT, we trust everybody on the NAT, and nobody actually uses the third model in IPv4 infrastructure. Therefore, you know, we're back to the 1970s. Hey, peace, I trust everybody. IPv6 has a different model. IPv6 still has the I trust everybody model, but you know we've proven that that's really wrong. This is RFC 3577-76. It deals with that issue, but then it also deals with, should I trust everybody around me or should I just trust the router? Well, Model 2 says I just trust the router and I trust nobody else that's connected to me. The third model is I don't even trust the upstream router. I have to have proof that I should trust that upstream router. And it actually does a trust walk to validate that that router is who it claimed to be. This helps mitigate the man-in-the-middle attacks. These are where research needs to be focused on today, is to try to use some of these new IPv6 capabilities and security models. And again, with the v4 model, one of the big challenges we have is that we've dealt with IPv4 for so long that a lot of people are trying to apply IPv4 thought processes to IPv6, again, security models, and therefore they're actually making their products less secure. As an example, for if you've heard of SANS Top 20 list, well, I went through it recently and found out that they have 5 controls that if you follow their standard for IPv4, you would be secure. Again, based on those difference in models. But if you implement it with IPv6, not so good. So again, the security models, I think it would be a place for academic research, and also new defenses and new thought processes on defenses would be really amazing.
Yeah, absolutely. So, and do you think that not just, I guess, the security of the systems, but you know, certainly with IPv6, you get some more anonymity on the internet. How does this, if anything, tie into the next buzzword of the show, which is the dark web and the dark internet, and you know, what is actually going on in there, and does it have any relationship to, you know, making advancements in IPv6 deployment?
Well, my question is, who's it dark to?
Right. Yeah. No. Yeah.
I mean, if I have a server up on the internet that I have a trust circle that I allow to access that, I don't see that as being a problem. but it's dark to everybody outside of my circle, as an example. And if I see anybody outside of my circle scanning it or anything else, I know that they're a bad guy. Does that make
Sure.
sense?
Sure.
Again, something we can't do with IPv4 because of the address sizes.
Right.
So I think the other thing is we have to get over this issue of scanning the whole internet. I guess you've seen the mass scan issue where I can scan the internet in 45 minutes or whatever, looking for a single vulnerability. Current scan methods, brute force, could take millions of years. With a optimized version, there's several models there. Yeah, it's still going to take, may take days, but can't be optimized past that. And
Well,
that's only if people choose the wrong addresses or whatever. If they use a random address, it makes it difficult. So my question is the is the dark net bad or good? I don't know. I don't have a determination. I like the idea of having that dark net for, to protect my assets and be able to know that somebody is not authorized is trying to access it.
Sure.
Yeah, I think that yes, the additional address space will provide that issue. And you mentioned privacy there for a second. That's really dealt with the privacy addresses. And honestly, if you're using IPv6 today, you need to make sure your privacy addresses are turned on your device. What that does is that randomizes the last 64 bits on a random basis, so that if I go to a website now and I go to a website tomorrow, that address range will be different. That last 64 bits address.
Right.
That kind of makes a lot of sense. Yeah, it's gonna mess up a lot of advertisers, but
Yeah, and well, what does it do for, in Google's case, does the Google search crawler have to be, reworked in order to crawl sites that are now existing at randomized IPv6 addresses? And
Well, that actually is interesting because with IPv6, we have different, for a host, from a host perspective or endpoint perspective, we have different kinds of addresses. First, we have link local, which allows me to communicate on my link local unicast, which allows me to communicate on my local network. And we also have a link local multicast, which allows me to share data among all the systems. We have what is referred to as ULA, which was a unique local address, kind of like the RFC 1918-10 addresses, but they're a lot bigger.
sure.
So those were meant for the unicast, and the multicast are meant for an enterprise. And then we have the global addresses, both unicast, multicast addresses. The ability to register your device is what Google takes advantage of today. Most people register the domain name. And once you've registered the domain name, the only difference is, well, even today, Google has to do a DNS lookup to find out that IP address. Once they found that IP address, they'll be able to access that system. If that IP address changes once a day, and the inbound connection changes the actual IP of the host once a day, then does it really matter? They're still going to do a DNS lookup. Does that make sense?
Yeah. Yeah. Absolutely. Well, it just, I guess from Google's perspective, it's not, as big of a deal as, but, when we talk about, random bots that are trying to scan and find, where all the websites are on what IPs or where all the services are throughout the internet, makes obviously, you said earlier, that becomes, significantly more complex in terms of how long it takes to compute that, if you're doing that in the IPv6 range.
Absolutely. They're going to have to rely on DNS. They're not going to be able to rely on IP only.
Right.
Unless, again, people create bad IP ranges. One of my favorites is that people will use the last octet of their IPv6, the last 64 bits, they'll call it the port number. As an example, their DNS will be 53 and their web server will be port 80 and their, whatever kind of makes it easy to find, or the router is 1 and 2.
Hmm.
So it kind of makes it easier to find, in that perspective.
Sure.
So there's some education that has to take place on people that architect IPv6 networks.
And we were looking at that IP Viking tool earlier this week, which shows you pretty much in real time all the worldwide hacking attacks people are letting loose on each other. Does that also look different in a IPv6 only world?
Yes, it would look a lot different. What you're talking about is the Norse.
Yes.
Yes, that cool product. It's like the old school missile command.
Yeah.
If you think about it, the only thing a friend of mine said, the only thing that's missing is the pew, pew, pew. So,
Yeah.
that's about it. But yeah, that was showing sources and destinations of connections. And yeah, I think that will change a lot with everything from changing addresses within a segment to maneuvering networks, which is something that has been discussed for a long time within the IPv6 network, where my network will be readdressed. The first 64-bit part of that will be readdressed, and I'll just move someplace else to avoid a denial of service or to remove myself from an attack position.
Right.
So I think that changes, again, the way that we deal with networks. And yes, it will make it harder to scan and everything else.
Just as a neophyte myself, representing the average guy crowd, I have a fair understanding of IPv4 and DNS and getting domain names and things of that nature. But when you go from the scale of 4 billion addresses to, what is it, 100 billion times 100 billion times a quadrillion addresses, does this represent some technical problems as far as update response times and for DNS servers and naming communities to keep track of this infinitely large number of addresses and associating DNS names and so on? I mean, it just seems like a totally different scale that you're basically applying a DNS model to.
Absolutely. To start with, it's 360 undecillion addresses.
Yeah.
Yes, there's a word.
That's really big.
Yes. It was even hard to look up. Hey.
Yeah.
So yeah, the DNS infrastructure has to stay stable. And people register those names, and they can now register those names. Many times there's a REST interface that I can register my names directly to the DNS, and it will then take on a specific time period and lifetime of that address for my web server or whatever. I think that we're going to see a lot of that being automated instead of being done manually. Based on trends that I'm seeing in the market. And as far as scalability, as long as I can find the .root that then allows me to point to the .coms, the .nets, the .whatevers, whatever.
Yeah, I guess I'm wondering, myself, I mean, I know Christian and I, in our dabblings, you put a website up and you register a domain name and you set the A record, and it takes, Christian, better than I do, how long does it take for that domain name to propagate?
I mean, it really depends on whether or not the name server has already been pre-established and defined, or whether or not you're changing name servers. If you're just changing the A record, if your time to live on the DNS record is small, then it'll be pretty quick. But if the name server itself, the authoritative name server, has changed, that can take up to 48 hours.
Right. And that's true with IPv4 or IPv6.
Okay, so that's what I'm saying. If you've got this model where you've got a website out there and it's changing its IPv6 address daily, does that? I'm having a hard time grasping as to how that doesn't create an issue of getting back to that website once that as frequently as that IP address is changing.
Yeah, that's actually a discussion about time to live.
Okay.
When I do a query against a DNS server to identify a host, I receive an address and I receive a time to live. I can choose to follow that requirement or that standard. I can choose to ignore it. Some applications totally ignore it, assuming that device is always going to be there. So there's a bit of a change in the way we think about things for that. As an example, our browsers cache things also nowadays.
That's what I'm wondering. So,
Yeah.
you know, isn't there going to be a lot of transition inside people's networks that are going to have to make adaptations to recognize and accommodate for the fact that these underlying addresses associated with these DNS records may be changing more frequently?
Yeah, that actually gets down to a new set of tools that companies that are moving to IPv6 are required to, or to just to be able to manage all these addresses. These tools are called network IPAMs, IP address management tools,
Yeah.
and many times they integrate into the DNS, the DHCP services, so that from a security perspective, I can always maintain context on where that device is within my infrastructure,
Okay.
which becomes really important, and that helps manage that movement. So you always know where that device is. You always know where it was yesterday and the day before that too, for forensics or for other reasons. So there's those kind of systems that have been around for a while that are now becoming popular within organizations that are dealing with this. This also takes on another interesting thing. Have you heard of DNSSEC and DANE?
Yes. Yes, I've heard of them. I haven't understood them, but I've heard.
Yeah, what that is that the root itself is signed, and it signs the authority of the next node down, and that next node down refers to and assigns the next node up, and it becomes cross-linked all the way down from the dot to the .com to the myname.com, scientifichooligan.com, which is my domain, to the that I actually manage then the www of the scientifichooligan.com component. So at any time with a protocol such as DANE, my browser or my application can actually walk that trust chain to validate that somebody hasn't done a man-in-the-middle attack or has falsified my upstream DNS or has falsified anything in the communications channel. IPv6, with the implementation of NAT, we've never really been able to take advantage of DANE and DNSSEC because we always have those intermediary boxes that do the man-in-the-middle and the address rewrites. With DANE and DNSSEC, it opens up a whole new set of opportunities, both for research and also for security, to ensure that when we're communicating with each other that, again, we can trust each other's DNS because we can walk the chain to validate that, and that you and I could put a public key out there so that when we received email from each other or a connection like this, that I could trust that connection from you, that it was truly from you. But again, that's some of the really cool things that are happening within the DNS infrastructure while you're implementing IPv6. And a lot of organizations are seeing it. This is the time to do it, just because of that, and also because of something else. You guys have you paid for a certificate recently, a SSL certificate or TLS certificate?
No, I don't pay for it. I just let people who come to the few sites that I run, they better know that you just forget the warning.
Well, with DNSSEC, it fixes that. It allows you to create your own certificates. So once you have the trust path established, you can create as many certificates as possible for your local segment, because your DNS is trust. Again, the trust chain comes all the way down to trust. Then you can create as many certificates as you want for every system in your network and as often as you want. That make sense?
Yeah, no, that's nice.
Yeah, so that's going to be a big cost savings, but it's also going to be a way of changing the security model for trusting devices even on my own segment.
Sure.
Okay.
And in case anyone missed that map link, which is pretty cool, you can check that out at map.ipviking.com, all one word, and you can watch cyber attacks across the globe happening in real time. So that's pretty cool.
I just posted the link in the chat.
Perfect.
Yes, and please, 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 on the chat, if you choose and you've actually looked at it, you can type pew, pew, pew for sound effects.
All right. Well, we've come up on the 1 hour mark. Is there anything else? Last minute thoughts, comments, or questions that we have?
As we were getting ready to get prepared to set up and log in, and I know that I'm just going to give this to whoever's out there that wants to make the next $1 million.
Billion dollars.
Probably $1 billion. I was brushing my teeth with an electric toothbrush, and I could just see myself turning that toothbrush off and having the notice come up on my Android phone that for best results, you really should have brushed 30 seconds longer with slightly more pressure on the left side of your, upper gum. And I think that's probably where we're headed with IPv6.
Well, once we have that connection, that data stream can be trusted to your Android phone. I can see it happening.
Or, and more likely, it'll probably be displayed right on your mirror while you're brushing your teeth,
That would be a little bit creepy. Sorry. I want to mention one other thing that is causing a lot of problems that you may want to be aware of. A lot of carriers have created a new set of NAT called CGN, or carrier grade NAT. This is very, very concerning for a lot of people. Specifically, what it does is today with your ISP, you have a single address for while you're connected. Carrier grade NAT, you're actually sharing it with your 1,000 best friends. No, actually not your best friends, but random people. And you only get a few seconds or a few minutes with that address, maybe 4 minutes, and then your device changes the address again. We have some really big concerns. Number one, applications being able to trust SSL certificates and connections going out to the net. Also, you're limited to how many ports, so applications that are using multiple, say, REST queries or queries out to other services are actually failing today going through this. Lastly, if that address gets blacklisted, literally you won't be able to communicate with something for 4 minutes, as an example, until you get a new address, and then you can communicate again with it. We have the major carriers that have not started the move. They chose to do this carrier grade NAT instead of moving to IPv6. Apparently, last thing, this also kills geolocation. So if you're looking for an attacker with an organization that's doing carrier grade NAT, you're going to get a choice of, wow, they were either from the East Coast or West Coast. So it's going to make security a lot more difficult for those carriers that have made that choice. I want to mention that because that's been a big thing spun up in the last couple weeks with some of my customers, is how do I know that it's, it's West Coast. What does that mean? Does that mean it's California and LA, or does that mean it's, Arizona,
Sure. And is that when you mean carrier, is that at an ISP level or a mobile device level?
At the ISP level. Right now it looks like Verizon and AT&T are two of them that have implemented this or started implementing this. So it looks like it's going to be very brutal for those that stay with IPv4.
Sure. All right, well, I think that's about it for this show. We'll be back hopefully in 2 weeks, 2 weeks on a Friday most likely, and we'll be back with our usual rotation of guys. Thanks for coming out, Joe, and hoping to keep expanding on the IPv6 knowledge for those that are listening, and start tying it into some of the other things that we talk about on the show, with both security related and data related, because I think this actually opens up an interesting model for how do you do big data on IPv6, which is a conversation I don't know how many people are having yet. So,
well, that's interesting. We will talk offline or maybe the next time.
Sure.
There's actually IP addresses set aside specifically for that kind of framework.
Yeah, that's pretty cool. Absolutely. All right, guys, this has been show number 5, and thanks for listening. Have a good evening.